We are now looking at the Spring project structure. So first we're going to look at the pom.xml file, and that's what we have here. So we're going to open this. Line 5, the parent, is going to introduce us to the parent element. We will be coding the child for this. This specifies the project has a Spring Boot starter parent as its parent pom. This parent provides dependency management for several libraries commonly used in our Spring projects. For the libraries covered by the parent pom, we don't need to have a specific version because of inheritance. So basically, we use this parent. We are going to inherit whatever our parent has whenever we make that child, so we don't have to specify a version. The version indicates a specific version of Spring Boot. Thus, we'll inherit dependency management as defined by that version of Spring Boot. Now we can look at the dependencies. We look no further, but this little menu pops up down here. Now, if we go somewhere else, like let's say here, it's not going to be here. Only when we go to the pom. We have our overview. We have our dependencies. We have our dependency hierarchy. We have our effective pom, and then our pom.xml. What we want is our dependencies. So we have Spring Boot Starter, Thymeleaf. We have our Spring Boot Starter Web, Spring Boot DevTools, and Spring Boot Starter Test. There are 4 dependencies declared under the dependencies element. The first 3 correspond to Spring Web. The first 3 corresponding to Spring Web, Thymeleaf, and Spring Boot DevTools that were added to the project when making it in the previous video linked below the like button in the playlist are going to be these. Now, there is one of these that doesn't have the word starter in it. Spring Boot starter dependencies do not have any library code themselves, but instead they transitively pull in other libraries. Notice how all of them, but the dev tools, have the word starter in it. So the starter libraries offer the following primary benefits. We want to build a file. The build file will be smaller and easier to manage because one does not need to declare a dependency on every library needed. The ability to think of dependencies in terms of what capabilities they provide rather than their library names is also a plus. For developing web applications, add the web starter dependency rather than a laundry list of individual libraries that enable writing the application. So if we want to write a web application, which is pretty cool, and hopefully we get to do that, if we want to write this, it'd be much easier just to implement the starter web or the dev tools instead of having a bunch of libraries that we would need to import and worry about that. We're freed from the burden of worrying about library versions as well. It's all taken care of inside of here. Libraries bought in transitively will be compatible with a given version of Spring Boot. This leaves one to only worry about the version of Spring Boot that they're using, so that's all you have to worry about. The build specification ends with Spring Boot plugin. It performs a few different functions. It provides a Maven goal, enabling to run the application using Maven. Previously we've talked about our maven.cmd and then our Maven up here as well. It ensures that all dependency libraries are included with the executable jar and are available on the runtime class path. It provides a manifest file in the jar that denotes the Bootstrap class. So in our case, the Bootstrap class is going to be our Taco Cloud application. It's going to be this one right here, tacocloud.java. So it produces a manifest file in the jar that denotes the Bootstrap class as the main class for executable jar. Because we run the application from an executable jar, we need a main class that will be executed when the jar file is run. One also needs at least a minimum of Spring configurations to bootstrap the application. This is generated for us in the Taco class. One of the most powerful lines is our Spring Boot application annotation, which clearly signifies it's a Spring Boot application. So we can look for our Spring Boot application in our Taco Cloud application. We'll expand our imports, and then we have the @Spring Boot application here. It is a composite annotation that combines the @Spring Boot configuration, @enable auto configuration, and @component scan. For the @Spring Boot configuration, it designates this class as a configuration class. Although there is not much configuration yet, one can add a Java-based Spring Framework configuration to the class if needed. The annotation tells Spring Boot to automatically configure any components that it thinks we will need. The @enable auto configuration enables Spring Boot automatic configuration. We're going to talk more about auto configuration later, but for now, just know that the annotation tells the Spring Boot to automatically configure any components that it thinks it will need. The @component scan enables component scanning. This lets one declare other classes with annotations such as @component, @controller, @service, and to have a Spring automatically discover and register them as components in our Spring application context. Another important piece of our Taco Cloud application is the main method. So it's going to be this one right here. This is the method that will be run when the jar file is executed. This method is, for the most part, a boilerplate code. Every Spring Boot application we are writing, it will have a similar or identical kind of form to this. Boilerplate code is what we're dealing with here with Spring. Boilerplate code is a pre-written programming language, so here, that may be reused on various projects without modification. Our main method is going to call a static run method on the Spring application class. It's going to perform the actual bootstrapping of our application, creating the Spring application context. The two parameters passed in the run method are a configuration class and command line arguments. So we have our class here, and then we have our args. Although it's not necessary that the configuration passed to the run be the same as the bootstrap class, it's the most common and convenient typical choice. Looking at our Taco Cloud application.java or the main Java file, chances are we won't need to change anything about our bootstrap class. For simple applications, one may find it convenient to configure one or two components in the bootstrap class, but for most applications, if we want to modify anything that's not auto-configured, it's better to create a separate configurable class. So if you only want to change a few things, it's okay to write in here, but if we want to do more than that, we should make a separate configuration class, because that will not be auto-configured. That's it for going over the basics of these files. Now we're going to look at testing our application. So we'll be looking at the test for our main, but that'll be in the next video in the playlist link below the like button.